All right, 38. Let f and g have continuous first and second derivatives everywhere. If f of x is less than or equal to g of x for all real x, which of the following must be true? So f of x is always less than or equal to g of x. Derivative of f of x is less than the derivative of g of x for all real x. We have to think about that in a second. Second derivative of f of x is less than or equal to second derivative of g of x for all real x. Or the definite integral from 0 to 1 of f of x is less than or equal to the definite integral from 0 to 1 of g of x dx. Which of those seems to make the most sense? None of them? Well, what does the definite integral tell us again? Area under the curve, right? This is saying that f of x is less than or equal to g of x the whole time. So if we were to draw two just random graphs, let's say this is our g of x, this is our f of x. Right, f of x is less than or equal to, at one point is equal to, less than or equal to this graph the whole time. This is saying the area under f of x from 0, let's say, to here, 0 to 1, is less than or equal to the area under g of x. Does that make sense? Yeah, that's got to be true, right? This is saying the first derivative, the slope of f, has to be less than the slope of g of x at all times. Not necessarily. Look at the slope right here. This slope is positive. That slope is negative. That doesn't have to be true. Here, the second derivative has to be less than or equal to the second derivative of g of x. Well, this is concave up. This is concave down. Right? So this would be, second derivative would be greater here than it is right here. So the only one that works here is 3.